Do you ever feel like you're out of place? Well, we're about to do the 2021 AMC 10B problem 1, which was also the 12B problem 1. I hope you guys enjoyed it, but sometimes you might have felt like you were out of place, which is why you'd be lucky to have a quantum marker. You see, with the quantum marker, I can simply toss the marker up, and there it is. I'm over here. The quantum marker has allowed me to teleport. And so if you ever found yourself out of place on this test, I bet you wish you had a quantum marker. Let's get started. Well, what is my prediction for how the AMC 10B how it went? What was my Amy cutoff? You know, I don't really know. I had a tough time. Initially, I kind of thought it would be a little lower than the A because I felt there was a few trap answers in here that were pretty darn good, like number 2, which we'll get to. And, you know, I don't know, but now I'm kind of feeling like maybe a little higher. Maybe 111 again, right around there. I don't know. Hard to say. Hard to predict for me after this one. I didn't get a good feel for it. I have no predictions on the 12. Sorry, guys. Can't tell you. I have no percent chances of each one qualifying. We're all going to have to wait and see. But if you did want to know direct answers, you can go to AOPS forums when these videos are posted, and somebody will have posted a answer key thread. And they usually talk about those things and get it all figured out. And they're pretty reliable answers after about an hour when there's some discussion has occurred. So if you want to know if you wrote your answers down and you want to know if you got them right, you can go there first rather than skipping through all my videos to see what answers I got. But besides that, let's get to this problem. How many integer values of x satisfy the absolute value of x less than 3 pi? Good to memorize pi, 3.14, right? Everybody knows that. So 3 times 3.14 is 9.42, and you're looking for the absolute value of x to be less than that. It's obviously everything from -9 to 9. You could either think of 9 positive, 9 negative, and 0 and get 19, or you could use the formula b minus a plus 1, which would be 9 minus -9, which is 18, plus 1, 19, get d, and let's get on to problem 2. And here we are on problem number 2 from the 2021 AMC 10B. And bam, I gotta tell you right off the bat, I'm guessing quite a few of maybe you, hopefully not. If you're my viewers, of course, you would never fall for this trap, right? But there's a really good trap in this problem. I suspect a lot of the general population that does not really prepare for the test or hadn't seen a lot of these kinds of contests in the past, I bet many of them fell for this trap. And we'll talk about it here. What is the value of the square root of something squared plus the square root of something else squared? But here's the deal. This is a subtraction sign, and you need to remember that the square root of a minus b squared does not just equal a minus b. You didn't do that, right? Please tell me you didn't do that. Or leave me a comment and tell me how you did that. But I'm hoping you didn't, because that's not what this is. You need to know, it's fundamental knowledge. The square root of x squared is the absolute value of x. And as such, this is the absolute value of a minus b. And what that's going to mean is it's not just equal to a minus b. It could be. It's a piecewise function. It is going to be a minus b if, that's an if, that's called a condition that has to be met for it to be equal to this, if a is greater than or equal to b. But if a is less than b, you're going to have problems because it has to switch. They wouldn't do that on question 2 of an AMC math contest, would they? No, they did. Yeah, they did. Yeah. Okay, so how's it going to work? You need to know the approximate values. I teach this to all my students. The approximate value of root 2 is 1.4, and the approximate value of root 3 is 1.7. Why? So you can think about it right now. What is 2 times 1.7? Well, that's 3.4. That's definitely bigger than 3, which means this subtraction is actually negative. It's the A is less than B situation. That means it has to switch. It's going to be 2 root 3 minus 3 plus, the other one's a plus sign, no issues there, plus 3 plus, it should be a 2, but I got ahead of myself thinking about the 3. My brain does that sometimes. So negative 3 plus 3 cancels out, 2 root 3 plus 2 root 3, 4 root 3, and if you got C, see you guys in the next problem. Alright, so continuing on with the 2021 AMC 10B problem 3. Gonna be honest, I felt like this is the longest amount of time I've ever spent on any problem 3 in AMC 10 history. I don't know what it was about the wording, and if you were an international student where you're doing English as a second language, heart goes out to you guys. I think it was really challenging. Even for me, I have pretty adept English skills, and I was like, what am I reading? What is going on here? Maybe it was just me and the coffee or the caffeine hadn't kicked in yet. Let's see what I'm talking about. In an after-school program for juniors and seniors, that's not hard, right? There is a debate team. This is my first mistake. I assumed the debate team was the after-school program. Did you? Leave a comment. But it's that inaccurate assumption, as I would find out later. So there is a debate team with an equal number of students from each class on the team. Each class, I guess that must be junior class and senior class. Okay, because there's not like first period, second period. There's no classrooms, right? They haven't talked about any classrooms yet, so it must be that they're referring to that. And so we go, okay, so then I'm thinking, all right, so the after-school program has an equal number of juniors and seniors. This is what I was thinking. That's not the right rendering, though. Among the 28 students in the program, wait a minute, that'd be the end. That'd be 14 are juniors, 14 are seniors if I'm really understanding what I'm reading correctly, which indicates I'm not, because later it's going to ask how many juniors are in the program, and 14 is not one of the answers. That's a sign that you have not understood the English properly. So it was for me at least, and then I kind of racked my brain, what are they talking about? So among the 28 students in the program, so wait a minute, is the program the debate team? No, the debate team is a subcategory of the program. That took me at least 60 seconds to figure that out, but that's what they were talking about. That it wasn't that the program and the debate team are synonymous, no. And maybe for you, you didn't have that problem. Awesome for you. It delayed me a little bit. So of the 28 students in the program, 25% of the juniors, so these are juniors in the program, not on the debate team, in the program. And that's my first clue for how I finally got on track. I said, okay, let's say there's J juniors. Then 1/4 of J, okay, 10% of the seniors. 1/10, and I'm going to use S even though I hate S because it doesn't look like S if you don't take your time drawing it. It looks like 5. So 10% of the seniors are on the debate team. Okay, so this is the debate team, this is the program. Then I said, okay, there is a debate team with equal number of juniors and seniors on it, basically. If we translate what it means, that means these are equal, what they're talking about here. 25% of the juniors. I finally felt a little bit of comfort. Now we can say J plus S is 28, because those are the students in the program, and there's only juniors and seniors. Okay, finally, how many? Now it's a system of 2 equations and 2 unknowns, and we get busy quickly because we've lost time trying to make sense of what we were reading. So 10 times both sides is going to give you 2.5J equals S. And I did write it as a decimal. Sometimes I do decimals, sometimes fractions. I don't know. I pick in the moment. It seems whatever seems best. So if I can replace the S with 2.5J, I'm not going to do a whole equation and write that. Not during a competition when those seconds are ticking down. You feel that clock ticking on you. Just plug it in mentally. You're going to get 3.5J equals 28. Now at this point, I said I'd like that to have a 7, because that's got a 7. And I'm going to multiply by J equals 28 times 2 over 7. Okay, if you don't understand what happened, this is 7 over 2, and I multiply by the reciprocal on both sides to get rid of that 7. I liked that better than 28 over 3.5 for reasons. But it's not that bad, actually. I guess you could do 56 over 7 and also get 8. It's not that bad. You just gotta be creative. Be quick about what you're doing, and you're probably fine. 7 goes into 28 4 times. 4 times 2 is 8. That must mean there's 8 juniors. And if I plug the 8 in here, I would get 2 equals 1/10 of S, which would mean S needs to be 20. Why are we doing this? It just asked how many juniors were in the program. because we want to verify because of all that weird reading that we didn't make a mistake. That's all. We're just trying to make sure we haven't made a mistake. So I take this 20 and the j that was 8, and I'm going to take both of them, plug them in right here. It does make 28. We feel a lot better about whatever the heck this was. Let's just forget that, right? And move on to question 4. The answer is going to be C8. We're on to question 4. Not quite unscathed, but maybe we lost a little bit of time for sure in that problem. If you didn't and you just went right through it, no issue. Good for you. I'm on to the next problem. And here we are continuing with the 2021 AMC 10B problem 4. It was also the 12B problem 2, and it's time to make up for some lost time, at least it was for me. Luckily, this problem directly connects to another problem, and that is the 2001, shockingly enough, AMC 8 problem 24. If you had ever done most of the old AMC 8s, or maybe you were younger at that time and did this when you were practicing for the AMC 8, you might recall this problem. I'm not going to go through the whole thing, but basically there was a triangle above and it had equilateral triangles on it, like this, and it folded down or something like that, or diamonds or something, I think triangles. And you folded it down, some were red, some were blue, some were white, or something like that, and you had to make pairs of them. Well, the strategy that I use in solving that problem when I teach my students is the same one we're about to use now. So this again is why we want to know all the historical problems, because they contribute to how fast you can do modern day problems. Let's go. At a math contest, 57 students are wearing blue shirts and another 75 students are wearing yellow. Pause. 132. Good. It tells us that there are 132 students, and there's going to be 57 for blue, and there's going to be yellow 75. The 132 students are assigned into 66 pairs of students, kind of like pairing the triangles. In exactly 23 of these pairs, both students are wearing blue shirts. So that would be like the BB pair if I've got 23 of these pairs, not 23 students. That would be weird because you can't have whatever. But 23 pairs of students, that's 46 students. So 46 students are going to be a double blue. What does it mean? It means 11 are not a double blue. And as a result, those 11 must be paired with someone, and there's only blue and yellow to go by. And so it must be that they are paired with a yellow-shirted individual. So if there's 11 of these, what does it mean? It means on the other side, 11 of these yellow are going to be paired with blue, because these are the same pair right here. They're part of the same group, blue and yellow mixed together, right? And so then that means if I take 75 minus 11, there will be how many students? 64 students, not pairs, 64. But if you didn't catch that, they are so happy to oblige and give you 60. Good job, you got 64. Sorry, I hope that didn't happen to you, but that is a little risky. It's not as bad as the trap on 2 in my opinion, but it is a pretty good trap because you know this is something significant, and because it's so significant, we sometimes get a little, oh, I've got to finish faster, and we might make a mistake there. Probably you didn't, but you might have, and sorry if you did. So what are we looking for? Keep going. In how many pairs and how many pairs, not how many students, are both students wearing yellow shirts? If there's 64 students in yellow pairs, there must be 32 pairs. And that's the answer, 32 pairs of students wearing yellow. Go look this problem up. Think about how we did this with the pairing like this. Do that one in a similar way. It'll go a lot faster in my opinion if you think about it that way. See you guys in the next problem. All right, the final problem of this set, which is the first 5 of the 2021 AMC 10B. I try to film 5 at a time for these tests, usually 1 to 5, 6 to 10, 11 to 15. After that, it's sometimes I'll hit and miss, like maybe miss one problem in the 16 to 20 or something. Or I'll film it later at some point. The ages of Joni's 4 cousins are distinct single-digit integers, positive. Obviously, there's an age, right? You're going to have a negative age. We don't have that technology yet. 2 of the cousins' ages multiplied together give 24. Process the information immediately. Don't keep reading. Make sense of what you just read. The options are 8 and 3, or it could be 6 and 4. That's it. 12 and 2 doesn't work. Why? Single digit positive integers. So it's one of these two. The other two multiply to 30. Well, what are 30's factors? 30 and 1, not going to work. 15 and 2, not going to work. 6 and 5, 10 and 3. All of these have an issue, and that's that they have two-digit numbers. So for the 31, it has to be 6 and 5. That means this combo is out, and these ones are 8 and 3. What is the sum of the ages? 11 plus 11, 22. Answer choice B. Let's get to the next set of 5.